Now we're dealing with probability of two events going on at the same time. Use the spinner below to find the following probabilities, numbers 19 through 23. So we have here the probability of a 3 here and a yellow. Well, and as our key word, that's going to be multiply. So probability of 3 here is 1 over 8. The probability of yellow here is 1 over 4. We see the word and we multiply. That's going to be 1 over 32. Now we have and or and a lot of us look at this and say, well, I don't know what to do. Well, you have to separate it. Say, I'm looking for the probability of 1 or a 2 and a red. So I got to find the probability of 1 or 2 and then multiply that by the probability of red to get the probability of getting all of that. So the probability of a 1 or a 2 is 1 over 8 plus 1 over 8, which is 2 over 8, which is 1 over 4. So I've got that part, and I got to multiply that by the probability of a red, which in this case is 1/4. So I'm going to multiply that, and that is 1 over 16. Now the probability of less than or equal to 4 and yellow or blue. All right, so this is a little bit more complicated. Yellow or blue. Let's go ahead and do this one first. Yellow or blue, that's going to be 1/4 plus 1/4, which is 1/2. So I've got 1/2 times probability of less than or equal to 4. Remember, less than or equal to includes the 4. So I've got 1, 2, 3, 4, 5 over 8. That's 5 over 8. And now I'll multiply those. That's going to be 5 over 16. 5/16. Number 22, I had the same sort of problem. Let's take a look. We got and, so we're never going to be multiplying. Greater than or equal to 3. So I include the 3 greater than or equal to. So it's going to be 1, 2, 3, 4, 5, 6 over 8, which is 3 over 4 times not green. Well, green is 1/4, so therefore everything else is 3/4. So we're going to multiply that by 3/4, and the answer is going to be 9 over 16, which is 9/16 for number 22. Now we have less than 3 and green. So the probability of less than 3 does not include the 3, it's just less than that. And that's 2 over 8, which is 1 over 4, times green, which is 1 over 4, and that's 1 over 16. In a hat, there are 10 marbles. 6 of the marbles are red. Give the probabilities for 23 and 24. Number 24, this is very, very much like the ones we see on our quizzes, 2 times. Okay? Here, the marbles are replaced after they're picked. So that's very different than when they're not replaced. So, 3 marbles are randomly selected. What is the probability all 3 will be red if they are replaced after each draw? Well, that means our numerator and our denominator are not going to change after every time. They're not going to change. These are independent events because we're putting the marbles back in there. And this is an and question. We're going to be multiplying. So, what is the probability of drawing a red? 6 over 10. What's the probability of drawing a red? 6 over 10. And a third, 6 over 10. Well, now all we do is simply multiply these out. Now my suggestion to you is to go ahead and reduce these ahead of time. And that's going to make this 3 over 5 times 3 over 5 times 3 over 5. And that's going to leave us with 27 over 125. And that does not reduce. Let me double check, make sure that does not reduce. No, that does not reduce, so it's 27 over 125. Now 25 is different. 3 marbles are randomly selected. What is the probability that all 3 are red if They are not replaced. Therefore, we're going to have dependent events, and our numerator is going to change as well as our denominator. So the first one is still 6 over 10, which is 3 over 5. But now, one of the red marbles has been removed, as well as one of the overall marbles. So our numerator and denominator are going to change on the second pull. It's going to make it 5 over 9. And then for our third, it's going to be 4 over 8. And now we have to multiply this guy out. That's going to be 720, I believe, right? Over, let's see, that's 30 times 4 is 120. That's going to be 12 over 72, which is going to equal 1 over 6. 1 over 6. So remember, our numerator and denominator are going to be changing on ones like number 25 where they are not replaced. Because by definition, if we're pulling 3 in a row, the first one we pull has to be red. So our numerator and our denominator are both going to change as we've done right here. I will give you these formulas for slope. The equation of a line or a linear function is y equals mx plus b, where m is the slope, x is the input, y is the output, and b is the constant or the y-intercept. As we know, slope is rise over run, or we can also get it with the formula y2 minus y1 over x2 minus x1, or y1 minus y2 over x1 minus x2. The y-intercept is where the straight line intersects the y-axis. This is something we've talked about in class. Well, let's talk about word problems. And this is what you're going to see on your final. Now remember, I'm going to probably ask you to graph these, but you don't necessarily have to. Okay? And this is one we did in class. Mary is trying to get in shape. She decides to go to Kennesaw Mountain and walk up the side of the mountain. Her personal trainer has told her the best way to get her heart into shape is to walk at a constant speed and incline. And constant speed and incline is basically my way of telling you this is going to be a straight line. And all of these are really. That's the only way you can really measure a slope in the first place. Mary begins her walk at the base of the mountain, which is 500 feet above sea level. Over the next 4 hours, she will walk and end up 1,300 feet above sea level. Mary walked at a constant speed and incline. So basically, she moved from 500 feet to 800 feet over 4 hours. Okay? So her rise, which is the output, is going to be the difference between these two. And you can do that y1 minus y2 over x1 minus x2 if you want. Or you can just say, hey, she rose 800 feet in 4 hours. Therefore, her slope is 200. In other words, for every hour she walked, she rose, went up 200 feet. Mary walked at a constant. So now you need to answer these questions. What equation represents her elevation at any given time? Well, now, if we can find an equation, we can tell what elevation she was at any time, either after she started, or even if we knew she was going to keep walking forever, we'd know what her elevation was at any given hour. Well, now we know that the slope is 200, so we know y equals the slope of 200 times our input, which is the number of hours, plus b, which is our y-intercept. Well, if you graph this, and you guys did this in class, you'll see that we started at 500 feet. As we learned in class, the equation is y equals 200x plus 500. The slope is 200. The y-intercept is 500. The input, in this case, x is the number of hours walked. And the output is the elevation. The elevation she's at. Now on the test, It's very important. You cannot tell me that the input is X and the output is Y. You have to tell me what each one of these represents. Okay? In this case, we would plug X in here, which is the number of hours she walked. And our output would be the actual elevation she is. And we could try this with 4 hours. 4 times 200 is 800, plus 500 is 1300, and we see that here. And you can also do this by graphing it. I'll give you plenty of graph paper. I will be giving you plenty of graph paper for the test. Word problem B. Mary is trying to get in shape. She decided to go to Tiger Park in New Orleans. This is a very, very, very similar problem to what we had before. Except in this case, she's in New Orleans, which much of that city is underwater. So it's possible for her to, or it's not underwater, but it's under sea level. So it's possible for her to start at a place like 200 feet below sea level and then walk up to an elevation of 700 feet above, which means she rose 900 feet. Okay? And she did this over the course of 3 hours. And we did this in class. I'm just going to go over it with you here quickly. Now our slope is therefore going to be, because this is the rise, this is the run, our slope is going to be 300. Our y-intercept, you need to think of your y-intercept as of where we started. At the very least where she was. Well, in this case, it's going to be a negative number because she was below sea level. So now we have our slope, and we have our y-intercept, which is going to be negative 200. And now we have everything we need to write our equation. Y equals mx plus b. That's y equals m, which is slope 300. And this, in this case, it's plus a negative 200. Let me start all over. And how you would write this normally would just be y equals 300x plus a negative is the same thing as saying minus. Okay. So now you've got your equation. Now you can figure out at any given time at hour 1, hour 2, hour 3, hour 4, hour 20 where she ended up. Your input in this case is x. This is also hours. Output is y. That is elevation. The y-intercept is negative 200. You have to make sure it's negative 200. The slope is 300. Jason's water pipes busted because of extreme cold. He now has to call a plumber to come out to his house and fix it. The plumber charges $50 an hour plus $150 just to show up. Jason's pipes gets fixed after 5 hours. Well, in this case, we don't even need to graph anything. We've been doing these types of equations from the beginning of the year. And you know that this is 50x plus 150. Well, we already know then, if we have our equation, this is the slope, this is the y-intercept. Our input is the number of hours the guy worked, and our output is the cost. So this equation represents, what's the slope? Y equals mx plus b. Well, we've got 50 here. We've got b, our y-intercept, which is right there. Our input, again, is the number of hours. Our output is what the cost was. This one we're going to have another negative y-intercept, and you're going to graph this one. I'm just going to show you, because he starts in the hole, he had to borrow $1,000. That's going to be a negative $1,000, but he plans on making $200 a day. Okay? Therefore, our equation is going to be y equals mx plus b. Y equals 250x minus 1,000. Okay? This is the equation. The slope is going to be 250. The y-intercept is going to be negative 1,000 where it crosses the y-axis. And if you graph this, you'll see what I'm talking about. The input is the number of days, how many days he's working. Again, we covered this in class, so I'm going fairly quickly. And the output is the amount of profit he will have. All right, now you're going to say, well, at the end of the first day, he's going to have $250 minus $1,000 for a profit of negative $750. Well, that's right. All right, at this point, he hasn't made any money yet. It's going to take him 4 days before he breaks even. In business school, if you go to business school, you'll learn that this is something called a break-even analysis, where the line crosses the x-axis, but you'll get into that more next year. And finally, E. Let's take a look at the last one. This one, Paul doesn't have to borrow any money on this one. Again, we go over this class. I'm going to go over it fairly quickly. But he's going to earn $300 a day. So Y equals MX plus B. Y equals 300X plus 0. And we would just leave that off, and our equation would be Y equals 300X. This is the equation. Our slope is 300. Our y-intercept is 0. We don't have one. Our input is the number of days he worked, and our output is how much he earned.